each of the notes goes back to the homework completion example that was in the intro pages. And in this example, I'm only going to do the test, but this test is of no difference. And so this test is not going to get pooled, unlike the examples that you did in the example pages. This one does not get pooled. So let's do it. P sub 1 is the homework completion rate. Completion proportion at school 1, and P sub 2 is, well, I should say true homework. The true homework completion proportion at school 2. Okay, and then they gave us that school 1 was the true value. They believe it's 0.70, and they used a simulation in the intro for that, and there's school 2 at 0.5. But the reality is we do not know the sample values. We don't know the school 1 sample value. We don't know the school 2 sample value, but we do know that the guidance counselors got together and they found the difference themselves of 0.1. But we see that the true value is believed to be 0.7 minus 0.5, so the true value is believed to be 0.2. And so we're going to look at an interval, and we're going to look at a test on the next page. So interval on this page, test on next page. But before we can do anything, we have to do our conditions. So random, and it was an SRS at each school. We're going to check that it was independent. They took a sample of 100 students, so we are going to have to check, is n less than or equal to 10% of n? This would be at school 1. Is school 2 less than or equal to 10% of n? This is at school 2. So we have 100 students, and we had 200 students at school 2. If more than 1,000 at school 1 and more than 2,000 at school 2, then we are independent. Let's check if it's nearly normal. So let's move this up. Nearly normal. And so now we need the n times p to be greater than or equal to 10, and the n times q to be greater than or equal to 10. P greater than or equal to 10, n times q greater than or equal to 10, and that's going to be for group 1 and for group 2. I'm just like highlighting the fact that you have to check it for both groups. So let's check group 1. 100 times 0.7 greater than or equal to 10. 70 is greater than or equal to 10, but that's not going to control this. The 30 will. So 30 is greater than or equal to 10, and then both of these are going to be the same. 200 times 0.5 greater than or equal to 10. So 100 is greater than or equal to 10. So yes, it does meet the nearly normal condition. I just want to point out that when we're doing this check, note, use P and P sub 1 and P sub 2, not the sample values when you're checking your conditions if possible. But if you don't have the Population values, of course, you would have to use your sample values, but if you could, you would try to. So, conditions for inference met. We're going to do a 2-sample z-test for difference of proportions. And let's do it at an alpha of 0.05. And we know that we think the true difference is 0.2. And we're looking at this 0.1. I'm going to try to decide, do we feel like we're looking for less, more, or different? And I think that we're just wondering if these two schools are different. And so I'm going to also do the other side. I'm going to double this level. So, okay, let's plug these things in. We need to write our hypotheses. We believe the true value is 0.2. Our alternative is that it's not equal to 0.2. Now we're going to do our z-test statistic, which is going to be the sample value, the difference of the samples, which was 0.1, minus the difference of the parameters, which is 0.2. And then I do need to get my standard error for this difference here. So this is group 1 minus group 2. So I will put into here, I am not going to pool. See, at this point you might have thought, well, let's pool this, but don't pool this because you do not pool when you've got a hypothesized value that has a difference. So let's put in this value. We've got 0.057879. So I'm going to put that value right here, 0.057879. So my z-test statistic comes out to be negative 1.7277. And now I'm going to slide this down so I can have some room to write. Okay, what's the probability that a z goes below a negative 1.7277 is 0.0426 ... Multiply that by 2 because we're doing two-tailed, 0.085. And now we will write our conclusion, and then I think that's the end of 10.1. Okay. Since the p-value of 0.085 is, let's see, greater than alpha equal 0.05, we fail to reject the null hypothesis and there is not significant evidence of the proportions, the difference in homework completion portions being different from 0.2. Done.